Hello everyone, my name Laras Prastio Adi, school ID 112568403, and welcome to this video. Today I will explain a program for final project in advanced C language class that simulate a basic file system in memory. The code handles basic files commands similar to those you might use in a terminal, such as listing directory content, changing directories, creating and removing directories, adding and retrieving files, and more. In this video, I'll guide you through each part of the code and breaking down how it works step by step. We will also run the program in the command prompt to see how the code behaves in real time, which will help clarify its functionality and structures. So let's dive in and start by looking at the overall structures and goal of the program. Before we dive into the details of the code, let's get an overview of how the program is organized. The code is split into several files, each with specific roles in simulating in-memory file system. So understanding this structure will help navigate the code more easily. First, we have the main C here. This is the entry point of the program. It contains the main function, which initializes the system and then presents option to the users for loading or creating a partition, and then enters a loop to process user command. For example, the code prompt the user with this one, and the other is the comment.h and the comment.c. This file contains the definition and implementation of the various command handlers. Uh, those are a function that performs a specific action when a user types a command. For example, in comment.h, for example, the handle ls and handle cd listing file, and also the check directory. We can see the detail in a comment C here. I will explain the detail later. And the other one, we have the partition.h and also the partition.c. These files define the data structures and function related to the file system partition. And the partition acts as a storage area where the directories and files are managed in memory. For example, in partition.h, the partition structure is defined as this one. So this tells us that a partition keeps track of its total size, how much space is used, and pointers to the root and current directories. Meanwhile, in partition.c, uh, implement function like create partition, save partition, save directory, etc. So basically, by spreading the code in this way, main C handles the overall program flow and user interaction, and then the both commands.h and command.c manage the individual commands and how the program respond to user input, and both partition H and partition C deal with the data structures for storing files and directories, as well as saving and loading data. Now that we have an overview of the file structures and what each part is responsible for, let's move into the next section where uh, we'll start examining the code in more detail, beginning with the main.c. So the file main.c serves as the entry point, front end, we say, of our program. It set up the environment and then takes user input for initial choice and then start the command processing loop. So let's break down its key component. The first one, we include several headers file. So this line imports standard libraries for input output, and then memory operation and also string manipulation, as well as the custom headers that define our partition and command functionality. Next, we see the process command function here, and in this function it creates an infinite loop that repeatedly first the print a prompt, so it's mimic the basic the command prompt display, and then read user input using fgets and store it inside input. And this one for the remove the new line characters, and then later compares the input against known commands and call corresponding handler function like maybe handle ls or handle cd. Now let's examine the main function itself. Here's what happened in main function step by step. First, displaying the code prints for loading and existing partition. So we call it uh, xx.dump for the extension, or we can also create a new partition in memory. And next, with the user input, it uses the scanf here to get the user choice and get char to clear the input buffer. Next, the handling choice. So if the user chooses to load from a file, the program reads a file name and then remove the new line, and then calls load partition to load the existing partition. This one is in the partition C here, load partition. Yep. And then if the user chooses to create a new partition, it asks for a size uh, and read the size. call the create partition to set up a new partition in memory. But if there is an invalid option is entered, the program prints an error message and exit. And the last, after successfully initializing the partition, it prints a confirmation message here and then calls process commands and then entering the endless loop of the process command. Eh, Yeah, this one here. And in summary, main.c is responsible for setting up the initial state of the program and then interacting with the user to decide whether to load an existing file system or create a new one, and then entering a loop to continuously process user comments until the user decides to exit. The next part of our program deals with the handling the various comments that the user can input. So this functionality is split between comments.h and comments.c here. Let's take a closer look. So in the comments.h, we find the declaration of all comment handler function. For example, this one handle ls, listing, file, change directory, make directory, remove file, and others. So this line tells us that there are functions. So they all take a pointer to a partition as an argument. So they know which part of the file system to operate on. Now let's take a look at the detail in the comment.c. Here's the beginning of the handle ls function from comment.c. So let's go through detail lines one by one. So this line defines a function name handle underscore ls. So the function takes one parameters pointer to a partition structures name partition, and then the void here at the start means this function does not return a value. And in this line here we declare a new pointer variable named current, and then that points to a directory. On the right side, the partition current directory or current dir accesses the current dir field of the partition structures. So essentially this line says take the current directories from the partition and store it in a new variable called current. So why do I did this? It makes the rest of the function easier to read and write instead of repeatedly writing partition current directory. You can just use current. So this line introduces the concept of pointers, holds the memory address of a variable in this case. So the directory currently being viewed. Then this line use printf to display message directory content here on the screen. It tells the user that what follows will be a list of what's inside the current directories. So what happened uh, after these lines? Although not shown above, the next part of the function typically involves iterating through the files and subdirectories of the current directory. So the function uses loops to go through each file and its subdirectory in the current and printing their names. The code will loop over the list of files in the directory using something like this. So the current file count tells how many files are in the directory. The loop goes from I equals 0, 1 less than file count. For each file, it prints the file name. Similarly, another loop will print its subdirectory's name. It's almost the same. Here, the current directory count is the number of subdirectories, and then the current subdirectories is an array of pointers to directory structures, and one for each subdirectory. So the code will print the name of each subdirectory followed by slash here to indicate its directory. So let's continue to the other command. For example, this one handle cd stands for change directory. So first, like before, defines a function that takes pointer to a partition, and then declares a character array to store the user's input. Next, prompts the users by printing enter directory names and read a line of the text from a standard input into the dir name. And again, removes the trailing new line so it won't interfere with the string comparison. Next, this set of lines, it will check the double dot here. So it will compare the dir name with the double dot. So if they match, the user wants to go up one level to the parent directory. So if the current directory has a parent, the code updates current directory to that parent. And then if it's already at root or no parent, it notifies the user. So already at the root directory. Next, this one for traversing subdirectories. So using for loops, will loops through all subdirectories in the current directory. Use this function strcmp to see if any subdirectory names match the dir name. If found one, updates current directory to that subdirectory and report success. And if no match is found, prints an error message directory not found. The next function or comments is the handle mk here. So the first set of lines here for checking the directory capacity. So ensures the current directory has not reached the maximum number of subdirectories. So if it has, the function prints a warning and stop. And the next, it will be also mostly the same with the other handles also. So it uh, you need to enter the file name, the dir name, sorry. And then similar to handle cd, it prompts the user and reads the directory name into the dir name. And again, removing new line at the end. So in this one, so basically this one will dynamically create space for a new directory structure on the heap, and then checks if the allocation was successful. If not, it will print the error. And user mem sets to initialize the entire struct to 0. Uh, and it will copy the user provided uh, name uh, into the new dir name here. And then the next sets of line, it will set the parent pointer to the current directory and initialize file and directory count to 0. Allocate array for a file and subdirectories. This one is for places the new directories pointer in the current directories subdirectories array. And then increment the directory count and print the success message. Yeah, directory created. The next commands is rmdir stand for remove directory. Again, similar to the previous commands, it will read the directory name and then prompt or print, for example, enter name of directory to remove. And later it will search, oops, sorry, uh, will search the subdirectories and loops over the subdirectories in the current directory to find a match by a name. And then yeah, in this one it calls free directory in partition.c. Yeah, this one in partition.c here. And then this one is to free all files and subdirectories basically, and shift subsequent entries in the subdirectories array to fill the gap. Uh, Next, it will decrement the dir count here because we delete one obviously. And if the loop finishes without a match, it will print directory not found. And then next one is handle RM. Uh, Again, for the first three or four rows, the same with the others. Command. So RM is done for remove, but this one is for removing a file. So it will compare each file's name with the user input and then removing the file. Once found, shift the rest of the array to fill the remove file slots and decrement the file count and informs the user of success. And if there is no file found, it will prompt file not found. Okay, again, this one is almost the same. So handle put, we use that to open a file on the real file system. And if it fails, it will print error and return. So this one is for the calculating file size and checking space. So basically it will move the file pointer to the end to get its size and then resets to the beginning with the rewind. And later checks if there's enough space in the partition to store this file. Uh, this one we allocate memory to hold the file's data plus 1 byte for uh, \0 and then read file size byte into file content. Uh, and this one will check if the directory can hold another file and creates a new file entry in the files array and copies the name, stores the size, assign the content pointer, and updates the partition use space. The next one, handle cat, again almost the same at the first four, 3, 4 lines. So here we compare each file's name in the current directory with the user input and then open or creates a file on the real file system in binary write mode WB here. Copies the in-memory content into the new file and close it and confirms success. And if no match found in the loop, it will print not found. Okay, next we have handle cat. This is for viewing the inside of file that we after we use uh, here handle put we can after we store a file, we can see what inside the file using this one, handle cat. So it will, oh, sorry, again, the first one is the same. And it will iterate through the files array of the current directory and display its content. So it will print the file name and its content to the console with this line. So if the loop ends with no match, again notifies the user. Next we have handle status. First, it shows how large the partition is in the total bytes, and then for the inode calculation, it will call this function, okay, uh, to recursively sum all directories and files and print total and used inode. The other one, breakdowns how many block exist using partition size, block size, and then calculates how many blocks are in use and how many are occupied by files. We have also the free space, display how many bytes remain unoccupied, and the next one we have handle x uh, first handle help, so simply prints a list of comments and short description. There's no interaction here with the partition structure, so it's just act as in-app reference for user who forget the comment. And the next one is exit, so it will calls a function save partition here from a partition.c to serialize the current in-memory file system to a file on disk. So after saving, reads a confirmation message. So once this function completes the main loop in process command, uh, this one will break and ending the program. And the next one, we will cover the partition.h and partition.c. Let's take a look at this one. So basically, the partition.h defines the key data structure used to simulate the file system, and these structures include file, directory, and partition. And let's see the details. First, we define a constant here. Uh, this for set the file name. It can be up to 255 characters long, and it used in this line. This field stores the size of the file in bytes, and since the file content can be varying in length, we use a pointer char to dynamically allocate the appropriate amount of memory when reading a file. Next one, let's have a look at the directory structures. We have the same line here uh, that holds the directory's name, and then this pointer point to the parent directory, and this is how the program maintains tree structures of directories. So if so, each directory knows where it came from, which is used to navigate up the tree, as we saw in the handle uh, CD when processing the double dot. And then uh, this pointer points to a dynamically allocate array of file structures. So instead of having a fixed number of file slots built into the structures, this design allows the directory to manage many files up to the limit defined by max file here. And next, the file count will it used for keep tracking of how many files are currently in the directory, and this pointer points to a array of pointers. It's pointing to a directory structures. And the last one tracks the number of subdirectories in these directories. And the last structures in the partition.h, we have the partition structures. So first, this one represents the total size of the partition in bytes, and then represent in this line represent how much space is currently used by files in a partition, and this one uh, is a pointer to root directory of the file system. So the root is the top level directory from which all other directories and files branch out, and this one is a pointer to the current working directory. Next, let's see the detail of the partition.c. So here we have the several commands to manage directory and partition. So here it contains functions that manage the file system partition, including initializing a new partition and saving it to the disk, loading it from disk, and freeing allocated memory. So let's take a look at the create partition here. So the function begins by setting the total size of the partition to the user provided value and initializing the used space to 0 since it's a new partition. And then immediately after setting these fields, the code allocates memory using malloc here for the root directory. Uh, and this allocate memory for a directory structure that will serve as a root, and the code will check if the allocation failed, and if so, it prints an error and exits. And these sets of line first mem sets set all bytes of the new root directory to 0 and ensuring a clean slate. And the root's name is set to the slash to represent the root directory, and its parent is set to null since the root has no parent, and file and directory counts are initialized to 0. Uh, and the memory is allocated for array of files and subdirectories within the root. This one, this means that after creating a new partition, the user starts at the root directory. Uh, Next, we have the save partition. So the function begins by opening the specified file in binary write mode (WB), and if it fails, it prints an error and return. And next, it writes the partition size and use space to the file using fwrite. So this stores the basic metadata needed to restore the partition later, saving the directory structure recursively, and the function then calls the save directory uh, to save the entire directory tree starting from the root. Next, we have the save directory uh, using fwrite. Writes the whole directory structure to the file, and this captures pointers and counts and saving the files in directory. And the first loop here goes through its files in the directory, and the second loop calls save directory on its subject directory and saving the entire tree recursively. And it saves its files metadata and then writes its content. Next, we have a load partition. Uh, the function opens the given file in the binary uh, read mode using this one RB. If unsuccessful, it prints an error, and it read the partition size and used space using fread, and then allocates memory for the root directory, calls load directory to recursively reconstruct the directory tree from the file data and sets the root parent to null and initialize current directory to the root directory to the root. After loading, it will close the file. Now let's go to the load directory. For you using every it load the safe directory structures. So after reading it, it allocate memory for the array of files and subdirectories based on directory file count and directory count, dir count, and load the file. So for each file, it will read the file's metadata, allocates memory for the file content, and reads the content into that memory, and recursively loading the subdirectories. These subdirectories, we allocate memory for the subdirectory and then recursively calls load directory to populate the subdirectory and then set the parent pointer to maintain the tree structures. The last command is the free directory. So this one, it will call the function calls itself recursively for each subdirectories to free the entire tree first. And for array, once all subdirectories are freed, it frees the subdirectory array by itself and iterates for the file content. It iterates over each files to free the memory allocated for each content. And for file array and directory, uh, it frees the files array and then finally frees the directory structure itself. So the explanation of the entire code is finished. So let's do the uh, demo of the code here. So first of all, I have two file here, hello.c and hello2.c. It's just uh, a simple C code just saying hello, and in hello.c it say hello2. Okay, to later we can demonstrate how to use the cat commands to view the uh, inside of the files, and also put command to put this file into the simulated system. Okay, let's try to make a new partition in memory. So I type 2, enter, and then allocate the memory. For example, okay, so this is the uh, like the mimic the command prompt I said before, slash dollar marks. And let's try using help to see the comment. Say it will print all of the available comment. Let's check the listing files. We use ls. uh, no file, no directory here because it's still new. Let's try to make a subdirectory mk here. Uh, Input the file, the directory name. Let's say folder one. Let's make another one. Folder two. Let's list the directory. We already have two here, folder one and folder two. And first, let's put the hello.c in root directory. Let's check. Yes, we have the hello.c here, and we can also view the inside of the hello.c using cat. Okay, then let's go inside the folder one and put the hello2.c in folder one. So we use cd for change directory and then folder one. Yep, we already inside the folder one and we use put to put the folder one. Sorry, the hello2.c. Okay, hello.c is already here. You can make sure using cat to view the what's inside the hello.c, hello2.c, sorry. Okay, and then let's demonstrate the how to delete the directory or how to delete the file. Let's go to the parent directory first. So cd and type double dot. Okay, and then let's first delete the hello.c. File remove. Let's make sure. Yep, it's already removed. And then for removing a directory, we can use rm dir and then folder. Again, checks. Yep, it removes. Let's try. Let's see. We already use ls cd put get. We haven't used this one, and then the status and help. Let's check the status first. Okay. We still have a free space. Let's put the hello C and then use a status again to see the difference. Yep, there's a difference here, and the inode is also different. Okay, and okay, let me build a free environment to demonstrate the get command. Oh, actually, I can use this one. I have hello.c and I have hello.c here. So let's just hide or change the name of the hello.c here. I will rename to try hello.c, and then I will exit and save the session to the okay stop stop. Okay, we already have the OK12.dump here. Let's rerun the uh, simulated system, and this for this time we use a load from file, and we load the OK12.dump. Let's check the inside. Yes, we have hello.c and folder. Let's check the inside also, inside the folder. Okay, we have hello.c. Let's go to the root directories. Since we renamed the try hello, we don't have the hello.c anymore. So let's try the cat command. We use cat and hello.c. Yep. Uh, with the cat, we can basically after we change the try hello.c to try hello.c, and then uh, use cat to retrieve back the hello.c here. Okay, let's okay, we tried all of the comments. So thank you for watching. Bye and have a good day.